So we've set up the basics on how to do substitution when we need to with integration. So I've already written this problem out. It's basically the population of a country was 5.216 million in 1990. The approximate growth rate, which is your derivative, of the country's population is given by f of t is this mess right here, which I wrote out, where t equals 0 corresponds to 1990. Okay, so here's the question. What on God's green earth do I have to do to this? Because I learned last time that e to the u, okay, as long as the derivative of u is 1, then I'm good to go. Well, the derivative of this is not 1. So all I did was pull the constant out front, and I'm going to use u substitution. So my u is going to be 0.1302 t. And then from there, I'm going to take the derivative of both sides. So the derivative of u is 1 du. The derivative of this mess is 0.01302 dt. So here's the issue. This is just a constant multiple out front. I need this portion and the dt. I only have the dt. So here's what we do is we balance. So since I need the 0.011302, I'm going to multiply this by 0.011302. But I need to balance by dividing by it. So remember, any number divided by itself is 1. So here's what we're doing. I've got a 0.06791232 times the integral of, now I'm going to randomly multiply by something. So 0.1302 e to the 0.01302 t dt. So now if you'll notice, I've got my e to the u, and I've got the two portions of the du that I need. But I can't randomly multiply by a number because I've thrown off the balance of everything. So I need to multiply by 1. So remember, any number divided by itself is 1. So I'm multiplying by 1. So I'm changing what this thing looks like, but I'm not changing what it is. Okay, so I took this constant multiple out front, and now I've multiplied by 1 so that I actually can rewrite this as e to the u du. So I'm going to go ahead and do this division in my calculator. And when I do that, I get 0.06791232 divided by 0.01302. Okay, when I do that, I get 5.216 times the integral of, and now this is now e to the u, and that's my du. Okay, so now look and see what we were given. The population of a country is 5.216 in 1990. So what did we just find? We just found out that it was 5.216 as long as this is 0, because e to the 0 would be 1, and 1 times this is 5.216. So we've used substitution to just verify what we had here. Now, when I integrate e to the u, what's the integral of e to the u to u? It's e to the u. So 5.216 is coming along for the ride. Oops, sorry. And then e to the u plus c. But I started in t world, so I better end in t world. So I'm going to replace this u with what I started with up here. So 5.216 e to the 0.01302 t plus c. All right, so back up for just a second. If I were to take this derivative, okay, I would drop this thing out front and I would multiply 5.216 by the 0.01302 t. Okay, and then, I'm sorry, I just totally butchered that. I feel like trash. If I were to take this derivative, I would rewrite everything the way it is times the derivative of my exponent. Okay, which means I would have gotten this thing back. Okay, so don't panic that all of a sudden I've got this multiplication by 1. This is still here. It's just hiding inside of the du with the dt. Okay, so don't panic about that. This is my answer. So this is the model I'm going to use. So when it's asking me for this, I don't know what it's asking me for. Hang on. What is the function? Okay, so I need to back up for just a second, and I need to resolve my plus c. Okay, so when I resolve my plus c, that's going to give me what the actual function is. Well, remember that this is 0, okay? And I need to have a 5.216, so e to the 0, 5.216. It ends up that your c is going to be 0, okay? This is my function, good and ready to go. So in 2011, what's my population going to be? Well, if I'm starting in 1990, 2011 is going to be 21 years. So now I can find out this, using this model, I can find out what that's going to be. So I've got a 5.216 times e raised to the, and I've got 0.01302 times how many years? 21 years. So I end up that this thing is going to be about 6.856. So 6.856 million people, or however many we're doing. It is millions of people, and it's to 3 decimal places. So that is the basics of U substitution, and we kind of dove in with a really messy one. So now we're going to backtrack. This is going to be section 5.2. I just finished up 13.2. I just finished up 13.1. That was the last problem. And so now we're going to rewrite this one. So I'm just going to use U substitution. It says U substitution. I call it U substitution. To find the indefinite integral. Remember, indefinite just means there's not tiny little numbers on top and on bottom. So I'm going to rewrite this thing. So it says 18 times the integral, and I'm going to bring this denominator up top with a negative exponent. So it says 3x minus 1 to the negative 7 dx. So how do I know that I need U substitution? Well, what is your inside? So my inside is 3x minus 1. Is its derivative 1? No. So we need U substitution. Okay? So my U is going to be what's on the inside. It's a 3x minus 1. Take the derivative of both sides, and I'll get a 3 dx. I've got the dx. I need a 3. So I'm going to balance by multiplying by 3 on the inside of the integral, and dividing by 3 on the outside of the integral. So what is 3 over 3? It's 1. I haven't changed what it is. I've changed what it looks like. So I've got what I need for my 3dx equaling du. So now what do I have? 18 over 3 is 6. And this now becomes the integral of u to the negative 7 du. There's your du. Well, this I don't know how to integrate, but this I do. So this is just increase your exponent by 1, divide by your new exponent. So that's going to become 6 comes along for the ride. U to the negative 6 over negative 6 plus c. So these 6's reduce. So I end up with this being, remember you started in x world, you better end in x world. So I've got a negative 1/6, because that's a 1 over a 6. Oh, sorry, I just lied. That's a negative, because my 6 is reduced. And then I have u to the negative 6 plus c. Well, what's my u? It's 3x minus 1. So 3x minus 1. So that is your answer. Okay? I'm pausing because my kids are coming in the front door. Whatever. All right, so the next one, I've got the integral of x squared times 4x to the third minus 5. It's underneath a radical or a square root, so I'm just going to raise that to the 1/2 power dx. So again, what's on the inside? On the inside, I've got a 4x to the third minus 5. That derivative is not 1, so I'm going to use u substitution. So my u is what's on the inside. And then take the derivative of both sides, so I get a 12x squared dx. Well, I've got the x squared. I got the dx. What am I missing? I'm missing the 12. So I've got a 12x squared, 4x to the third minus 5 to the 1/2 dx. So I multiplied by 12, but you better balance by dividing by 12, which is just 1/12. So this part is your du. So I've got a 1/12 u to the 1/2, and the rest of it is your du. So this was nasty and scary. This is the exact same thing. It's just that I made it simpler. So this now becomes the integral of u to the 1/2 becomes u to the 3/2 times 2/3. So 1/12 is coming along for the ride, times 2/3 u to the 3/2 plus c. And now I can clean this up. So I get 2 over 36, which reduces to 1 over 18. So I've got 1 over 18 u, which is really 4x to the 3rd minus 5, to the 3/2 plus c. And now we've used u substitution to get that all cleaned up. All right, so let's do, we got time for a couple more on this video. So I'm going to use, I've got a 7e to the 4k dk. So 7e to the 4k dk. And so what do I notice? I notice that my u is my exponent this time. It's where my variable is. And its derivative is not 1. Okay, so my derivative, my u is going to be 4k. Well, what's the derivative? Take the derivative of both sides, and I get 4 dk. I don't have a 4, I have a 7. Well, remember, I can bring that 7 out front to come along for the ride. So 7's coming out front because he's in my way. I've got e to the 4k dk, so what do I need? I need a 4, so balance by dividing by 4. So that gives me 7/4 times the integral of e to the u, so e to the u, and then this is du. And then what's the integral of e to the u? It's e to the u. So that becomes 7/4 e to the u plus c. But I started in k world, so I better end in k world. So that's going to be, look at me go, 4k. So 7/4 e to the 4k plus c. So take a derivative just to see if it works. So how do I take the derivative of this mess? The derivative of a constant is 0. I rewrite what's sitting here times the derivative of the exponent. So the derivative of 4k is 4, which would reduce with my denominator and leave me with just the 7. Okay, that's what I was trying to say at the beginning of the video. All right, let's do a couple more. I have, hang on, we have 4x to the 3rd. And then we have e to the 6x to the 4th. E to the 6x to the 4th dx. Okay, so what have I got to do? Well, the first thing I notice is I've got multiplication going on. I need to figure out where my u is. So since e is sitting there, I'm immediately drawn to my exponent. So my u is going to be 6x to the 4th. Well, then what's my du? My du is going to be drop your exponent out front. Drop your exponent by 1. So I have the dx. I got the x to the 3rd. I got 4 of the 24. So really and truly, I just need to multiply by 6. Okay? So if you want to bring that 4 out front and multiply by 24, divide by 24, it'll still balance out the same way. So basically what I'm going to do is I'm going to multiply this thing by 6 and then balance with a 1/6. So that's where the 24 came from, was I multiplied 4 by 6, balance with a 6. So now I've got a 1/6 of e to the u du. So how do I integrate e to the u du? The integral of e to the u du is e to the u. So that becomes 1/6 e to the u plus c. But you started in x world, so you should end in x world. So what is your u? Your u is actually 6x to the 4th. Okay, so that's your final answer. All right, we've got time for maybe one more. Let's see what it is. Let's not do that one. All right, so I'm going to pick that back up on the next video.